This is section 2.5. We're going to be finding zeros of polynomial functions. Another topic that you did in Algebra 2, which is most of these topics. Some of them we obviously go a little bit more deeper in. There isn't really much more to do on this topic, but we are going to go over this again. It is important for us to understand how to factor when we have polynomials that are greater than a power of 2. So we're going to talk about the best ways to find all the zeros of a polynomial, both real and imaginary. Okay, so basically what we're going to do is we're going to use these steps. And to me, this is a little bit different than what maybe the book will teach you because I think that there's a lot of things that we do that are a little bit outdated. So we're going to try and keep this as simple as possible. So the first step is we're going to use the graph to find easy zeros. That's the first thing. So once you know what one of your zeros are by using a graph, then we can use synthetic division to factor that out, to pull that zero out and see what we're left with. And we will keep repeating this step until we get only a quadratic left. Once we have a quadratic, then we can either factor or use the quadratic formula to find the additional zeros. So this will make a little bit more sense when we go through the first example. So our first example is 2x to the fourth minus 11x to the third plus 2x squared minus 44x minus 24. So if we go back to step one is to actually graph it. So I already have it graphed here, and let's see if we can make this a little bit smaller here. Okay, well, here, you can only see the graph here. So when you look at this graph, what I'm doing is I'm going to approximate what I think my zeros are. So I see that definitely I have 1, 2, 3, 4, 5, 6. So one of my zeros is definitely 6, and it looks like my other zero might be negative 0.5. So what that means is that if I know that my zeros are going to be x equals 6 and x equals negative 0.5, what I can do is I can synthetically divide using each one of these. So what I'm going to first do is I'm going to first synthetically divide with my 6. So I'm going to go synthetic division with 6. We're going to check to make sure that this is one of our zeros. And remember, for it to be a 0, it has to give us a remainder of 0 at the end. So we go through 6, we bring down the 2. This is 12, 1, 6, 8, 48, 4, positive 24, 0. Perfect. So because we got 6 as being one of our zeros, we verified it. We have now technically factored our function to be x minus 6 and then what's left over here is we have 2x to the third. Notice we have to go down by a power. Okay, we went from fourth power down to third power plus 1x squared plus 8x plus 4. So that's what we are left with. Now what we're going to do is we're not going to use negative 0.5 with this up here. We're now going to use negative 0.5 with what's left over, because the only way for us to break it down to a quadratic is for us to use the second zero on the cubic function to get it down to a quadratic. So I'm going to go negative 0.5 2, 1, 8, 4. Let's see what happens. Bring down the 2. This will be negative 1, 0, 0, 8, negative 4, 0. Perfect. We got a remainder of 0 again. So now we have determined that x equals negative 0.5 is one of our zeros. Now, this may take a little bit of thought, but now if we write out our factors, we know we have x minus 6. If we have negative 0.5 as one of our 5, but we really don't want decimals or fractions here, so what we can do is we can multiply everything by 2. So instead of it being x plus 0.5, it'll be x minus 6, 2x plus 1. That's what would yield us a negative 0.5. And then what we are left over with is 2x squared plus, and then it's 0x, so it's just going to be plus 8. Now, it looks like we can factor a 2 out of this. So I'm going to factor a 2 out. Notice how I always put the number out front. That makes the most sense. And then what we're left with on the inside is x squared plus 8. And hopefully what you can realize by looking at this is that x squared plus 8, that cannot be factored. Anything with a plus sign with no middle term is impossible to be factored, because if you think about foiling, if you have both minuses or both pluses, it's impossible for us to cancel out a middle term. Also, the other thing about this is if you can factor it, then there must be zeros involved. And if there's zeros involved, then it has to cross the x-axis. And x squared plus 8 is a graph that looks like this, if this right here was 8. So it never crosses the x-axis. So this is as factored as it gets. So in this case, if we're trying to find the zeros, there are no zeros from this one. We just have our initial zeros of x equals 6 and x equals negative 1/2 or negative 0.5. Okay, so hopefully that makes sense. Let's move on to another problem. Okay, so we have 6x to the 4th plus 7x to the 3rd minus 21x squared plus 35x minus 12. So let's put this in to our calculator. And let's see what our easy zeros. Our step 1 is to find our easy zeros. So we have 6x to the 4th plus 70x to the 3rd minus 21x squared plus 35x minus 12. For some reason this graph doesn't look right, so maybe just the window is messed up here. Okay, so this graph looks a little bit condensed here, so let's change the window. We're going to change our window to say -3 to +3, so that way we can see this a little bit better. Now let's graph it. Okay, so for right now, what we're going to do is we're going to use the 0 that we have here. Now, it's not always going to come out perfect. So sometimes you are just going to use the graphing calculator to solve for one of your zeros. So we do that by using second calc. You know, because that one doesn't fully look like it's at 1/2, but we're going to check just to make sure. So you can see here that we have a 0 after you use the calculator. It is, you know, maybe that's what you would have guessed, is it's 1/3. Okay, nothing wrong with it being 1/3. So what we're going to do is we're going to initially use 1/3 as our 0. So we're going to go 1/3, and then we're going to use our synthetic division, 6, 70, -21, 35, and then -12. 6 comes down, this is 2, 72, this is 24, this is 3, this is 1, this is 36, this is 12, and this is 0. So we get our perfect 0, which is what we're looking for. Once again, we don't want to write it as x minus 1/3. We would just write it as 3x minus 1. And then what we're left with is 6x to the 3rd plus 72x squared plus 3x plus 36. Now, there's a couple things you can do from here. If you want to factor out a 3, you can factor out a 3 first if you want to. Or what we can do is we can just continue to find one of our next zeros. So initially, you should have seen that, you know, we had this 0 up here, but we didn't see another 0 on the screen. So what I did was I expanded the window to find our other 0. And it looks like we're at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, -12. So that means -12 will be the other value that I checked. So I'm going to do -12 6, 72. And like I said, if you wanted to factor out a 3, you could. It's just not necessary at this point. So this will be 6. -6 times, or -12 times 6 is negative 72. And we get our negative 36, and we're down to 0 again. Okay, so therefore, we have now two factors. We have 3x minus 1, we have x plus 12, and then we are left with a quadratic here, which is 6x squared plus 3. And again, you could factor out a 3 here, so it's going to end up being 3 on the outside, 3x minus 1, x plus 12, and then x squared plus, 2x squared plus 1 in parentheses. Okay, so now, what I want to do is, let's talk about, so we have two real zeros here again. Our real zeros are x equals 1/3 and x equals negative 12. Okay, so those are our two real zeros. Now, keep in mind, on the last problem that we did, we had x squared plus 8. Now, because there's no real zeros there, we also want to talk about being able to find our imaginary zeros. So if we're going to try and find imaginary zeros, these problems are the easiest ones to use, because what I do is I go x squared plus 8 equals 0. I subtract 8 from both sides. I go x squared equals negative 8. Take the square root of both sides, and you get x equals plus or minus the square root of negative 8, and then you just reduce that. So when you reduce that, that will be x equals plus or minus I root 8. And then when you reduce root 8 is equal to root 4 times root 2. So 2 times the square root of 2. So therefore, x is going to be equal to plus or minus 2I root 2. So we have, those are our imaginary numbers, the plus or minus, and then there's our real solutions. So now we go to the next set over here, and we're going to do the same thing. We're going to end up with 2x squared plus 1 equals 0, 2x squared equals negative 1, x squared equals negative 1/2, and then we're going to take the square root of both sides, so we will end up with x equals plus or minus root negative 1/2, so x equals plus or minus I root 1/2. Now, this gets a little bit difficult because you got to realize that this is the same thing as plus or minus I times 1 over root 2. So we need to rationalize our denominator by multiplying by root 2 over root 2. So that means we're going to get plus or minus I root 2 over 2. Wow, that was great. And that was from the rationalize the denominator. And again, if you have questions about this, we can talk about this more a little bit in class. Okay, let's take a look at one more. Okay, what I want you to do is, I want you to do this one on your own. I want you to, this is negative 3x to the third plus 2x squared minus x minus 1. If you don't have a graphing calculator with you, then use Desmos to find the easy zero. But the good thing is once you find your easy zero here, there should only be one synthetic division and then a quadratic, and then check to see if you can factor it. If you can't factor it, then use the quadratic formula or square roots to solve. Okay? And then I want you to do the same thing for the last one. Okay? I want you to do the same thing. We don't need to keep going through these and make this video any longer than it needs to be. I just want you to try these two, bring them to class, and then we'll go over what the solutions are and see if you did them right. Okay? So I will see you then.